Okay, this is 9.3 arcs and central angles. This video should be pretty short because what they go over is more about definition and something that you already know than something new. Okay, all right. So the objective for this section is define and apply properties of arcs and central angles. Okay, so it's really understanding those words, and that's pretty much it. Okay, so here's the basic terms. The central angle of a circle is an angle with vertex at the center of the circle. So when we did the unit circle, we did it was like this, right? And the center is at 0. And then we did something like this, and this was a central angle. The central angle is the angle that are made by two lines that go through the center at the center. So that's the central angle. Okay, and an arc is this. That's an arc. It's the curved portion of the perimeter of the or the circumference of the circle. And this is a minor arc because it's a smaller. So it says this is a sign arc YZ. So this is a geometric figure. Okay, so you'd use a congruency. Okay, later you learn measure of arc, then you have an M in front of it, just like a measure of angle. Okay, so this is, if it says YZ, that's a minor arc. If you want to refer to this side of the arc, it's called major arc. You have to give another point and call it YWZ so that it can distinguish from YZ to YWZ. Okay. And the arc, if the line is a diameter, then arc YXZ is a semicircle. Okay. YXZ, and YWZ is also a semicircle. Okay. Measure of minor arc is defined to be the measure of its central angle. Okay, so the measure of YZ is just like measure of angle. It is a degree, and it is identical to the measure of the central angle. Okay, so the measure of the arc is the measure of the central angle that the arc is made up of. Okay, so that's just a definition of it that you need to understand. So in this case, the measure of YWZ is 360 minus 50, so 310, and so forth. And the measure of a semicircle is always 180. Okay, so this is a postulate. So you can add measure of arcs, just like you can add measure of angles. So if measure of arc AB is 90 degree and measure of arc BC is 110 degree, the measure of arc ABC is 90 plus 110 is 200. Okay, so that's the arc addition postulate, just like angle addition postulate. Okay, and congruent arcs, the congruent arcs are the arcs in the same circle in a congruent circles. Okay, so the first you have to have a same radius. You remember the congruent circle means radius the same, and that have equal measures. Okay, so the circle have to be congruent, and the measure have to be the same to be a congruent arc. So in the diagram below, the circle P and circle Q are congruent circles, and AB is congruent to CD because they're both 80 degrees, and also congruent to EF because these are congruent, same radius, congruent circles, and same measure. Okay, now this, the measure of arc RS is not, the RS is not congruent. Sorry, these are congruent, so you don't have M in front of it. Okay, these are congruent, so you don't put M, would make it equal. Okay, just like the angles. If you remember that, you'll be fine. This, even though the measure of arc RS is 80, these are not congruent because the circles are not congruent. Okay. The relationship between congruence of minor arcs and congruence of the central angle is stated in the theorem 9.3 below. Okay, so the 9.3 here, it says in the same circle or in congruent circles, two minor arcs are congruent if minor arc meaning the smaller one. right? Smaller one, the minor arc, are congruent if and only if their central angles are congruent. Okay. So that's just what we did. This one is a little bit elaborate, so we're gonna do this in a class, this problem. Okay, I'm gonna go over that in a class. And we're gonna do a couple practice. Okay, it's just not much. This chapter is very short. Okay, so find the measure of central angle 1. This is measure of arc is at 85, so this should be 85, right? This is 280, so this should be 360 minus 280. So it should be, well, you can do this one. And then this one, this is 150, and this is diameter, and this should be 180, so this should be 30, and this is diameter, so this should be 150. Or actually, this should be 150, right? This is arc, so this angle is 150. These are vertical angles, that's 150, and so forth. I think you can do these three. Okay. And at 11 o'clock, the hands of a clock of an angle of 11 o'clock, hands of a clock form an angle of, okay, 11 o'clock. So this angle is, the whole thing is 360 over x is 1 over 12. So you solve that and you get x. The hand of a clock from 120-degree angle at, and at the hands of the clock form 120 angle at what o'clock and what o'clock. All right. So 120, so it's something like this, right? This should be 120, this should be 120, this should be 120. So you figure out what o'clock these are. Okay? Draw a circle. Please place points A, B, C on it, such position that measure of arc AB and measure of arc BC does not equal measure of arc AC. Okay? So what that means is you have to place, well, my arc AC, okay, so arc A, B, and C. So measure of arc, let's see. Measure of arc AB and measure of arc BC, in this case, it's measure of arc AC, right? Because this is a minor arc. So how do we have to change that to not to make it equal? You have to make it the arc BC less than 180 because BC is a minor arc, but together with A, it become a major arc. So you have to say different angles. So let's put A over here, and let's put BC over here. Okay. So then measure of arc AB plus measure of arc AC. Now the measure of arc AC is this one, right? Because this is two letters, so you have to be minor arc. So it becomes this instead of this. This is a major arc now. This is called measure of arc ABC. Okay, this will be measure of arc ABC. So that's A. Does your example in part A contradict postulate 16? Think about that. Okay, so B is a homework. And I think let's do a couple of these and then you fill out the rest, okay? All right, so if the measure of arc C, so let's do this one, all right? And let's do a couple of these. And it's all question mark. Oh, because this is X. All right. If this is 60, what is 1? 1 is 60. And is 2 divided into here? Yeah. Okay. So this is isosceles, right? Because this is a radius. And if this is 60, this is 120. Right? These are lines. So this would be 120. I don't know if you can see it. 120. Right? So this is isosceles and this is 120. So this should be 60 divided by 2. So this should be 30. Okay? So you can do this one. And let's try when we know angle 1. So if this is 56, this is 56, and you can do the rest, right? And when this is 25, this is 25, so together that's 50, so this should be 130, yeah. So then this should be 50. Actually, this is external angle, so this should be 50 anyway. So this is 50 and 50, okay? You do the X one, okay? And this one, let's do couple them, and then you do the rest, okay? So if CB is 70 and BD is 30, measure of angle COD should be, this is 70 and this is 30, so this should be 100, okay? And CAD, okay, so it's the same deal. So if this is 30, this is 150, and this is isosceles, this is 70, so this should be 120, and this is isosceles. So you can do that one, you can do this one, I think you can do all this, okay? So do that and we are done.